Welcome to an introduction to educational research. This video will deal with group experimental designs. If you're not familiar with the concepts of internal and external validity as they pertain to research studies, I strongly suggest that you view the video titled Vocabulary and Validity, and you can see the YouTube URL in the yellow box at the bottom of your screen. So I would strongly suggest you watch that first prior to looking at this video. This video will present information on the group experimental designs and how each of these designs does or does not account for the various threats to validity in a research study. Before going on, I'd like to make one point or one distinction concerning research designs and their validity and how that affects the way that you may use them. Educational researchers approach designing and implementing research from a different perspective than from educational practitioners like you and I. They have a different view of research. For educational researchers, they're looking to discover or uncover educational strategies or interventions that can be generalized to all students. They're trying to develop a canon of knowledge that will be of use to all educators. They need to use research designs that have good internal and external validity and produce research results that can be trusted and can be generalized to schools. On the other hand, classroom teachers, in attempts to improve their teaching or to help their students learn or behave, are looking for intervention strategies that work well in their particular classrooms. Their emphasis may be less on the internal and external validity of the research study that they carried out in their classroom and more on, was the strategy effective? Did it work? Did the intervention solve the problem that I was trying to solve? Here's the takeaway from all this. It is important for you as graduate students to be able to read and analyze educational research and be aware of the strengths and limitations of the research studies and the designs that they use, and therefore knowledge of various research designs and how they control or don't control for internal and external validity is important stuff for you to know and will require you to metaphorically wear your formal researcher's hat. However, in conducting your own classroom research or action research project, the ability to remedy a classroom problem or to implement an effective strategy that helps students learn may be more important. If it works in your classroom or situation, then it has great value regardless of the design and its validity. The role of the researcher and the teacher researcher, although they may overlap somewhat, are very different. In reading and analyzing research articles, put on your formal researcher's hat. In your classroom, put on your teacher researcher's hat. Okay, now to the group experimental designs and their validity issues. And by the way, you'll need to put on your formal researcher's hat for this video. Suppose you decided to do a master's thesis, an actual scientific experiment, as your culminating product for your master's degree. Since you'll be doing a scientific experiment, the experimental design or the plan you select will dictate to a large extent the specific procedures of your study. So selection of a specific research design will influence such factors as whether you will have a control group and an experimental group, whether your participants will be randomly selected and assigned to groups, or whether you'll have to use existing groups like classrooms, whether your groups will be pre-tested or post-tested, how your data will be analyzed, and so on. So there'll be many factors that you'll have to consider. Different research designs or research plans vary widely in the degree to which they control for various threats to internal and external validity. However, some designs clearly do a better job than others. The purpose of this video is to list and explain the various types of experimental research designs or plans available to you, such as those in the white box that appears on your screen. Those are the experimental designs. In selecting your design, you first must determine which designs are appropriate for your study and for testing your hypothesis or answering your question. Next, you'll need to determine which of these designs or plans are feasible given the constraints you're faced with. If, for example, you must use existing classroom groups, then randomization is not going to be possible. And a number of designs will automatically be eliminated, such as true experimental designs, because true experimental designs require random assignment. But more on that later. From those plans or designs that are appropriate for you to use and are feasible for you to use, you'll have to select the one that will control for the most sources of internal and external validity, or in other words, will give you the most reliable and valid results. So, in this video, we'll take a look at 3 experimental designs. See the white box there? There'll be the pre-experimental designs, the quasi-experimental designs, and finally, true experimental designs. Pre-experimental designs do not do a very good job of controlling for threats to validity and should be avoided if possible. However, although their results are questionable, they can serve a purpose as a preliminary investigation of what might be an interesting problem or educational strategy you'd like to test out before going into a full-blown experimental study. They may be very useful when you have your teacher-researcher's hat on. Quasi-experimental designs do not control for validity as well as true experimental designs, but they do a much better job than pre-experimental designs. And they also may be very useful when you have your teacher-researcher's hat on. True experimental designs provide a high degree of experimental control and are always preferred. If feasible, they may be very useful when you have your formal researcher's hat on. So when reading research articles, it would be a good idea to know what kind of design the researchers are using. If it's pre-experimental or quasi-experimental, you need to interpret these results fairly cautiously. If it's true experimental and the study is done well, you could be much more confident in trusting its results. So we'll take a look at the pre-experimental, the quasi-experimental, and the true experimental designs. And the goal is that you will come away with an understanding of the strengths and limitations of each type of design and how they control or do not control for internal and external validity. We'll begin with some general information about experimental designs as a whole, and then we'll discuss the specific designs. The validity of an experiment is a direct function of the degree to which internal and external variables are controlled for. If variables are not controlled, it's difficult to interpret results or to generalize the results. As discussed in previous videos, the term confounding variable refers to interference or extraneous variables in the experiment. It's the noise that gets in the way, and they're variables other than the variables under study that may offer alternative explanations for the results. So the key issue when talking about experimental designs is the control of extraneous variables or confounding variables. Good designs control for confounds. the threats to internal and external validity. Poor designs do not. We will now take a look at the pre-experimental designs referred to as a one-case study design. The one-case study design consists of a selected group represented by the red box on the left side of your screen, and that group receives a treatment, and that's the circle with the X, and then the group is post-tested, and that's the green box with the O. Okay, and this is a very, very weak design. If you are wearing your formal researcher's hat, it's very weak. The only threats to internal validity that are controlled for are those that are automatically controlled because they're irrelevant to the design. If you look at the box at the bottom left, the checked boxes in the lower left corner of your screen are the threats automatically controlled for because they're irrelevant to the design. The unchecked boxes indicate uncontrolled for threats to the validity of the study. The threat of testing is a threat to the validity of this kind of a study, but it's automatically controlled for because there is only one test, so there's no pre-test, post-test. Testing is usually an issue when there is a pre-test or post-test, but in this case there isn't. The threat of instrumentation is automatically controlled for because there is only one test, so there's only one instrument, so there can't be any confusion. Statistical regression is controlled for automatically because there is no two scores. If a score can't regress to the mean if it's just one score. Selection or differential selection, where the experimental and control groups have different characteristics, is automatically controlled for by this design because it's irrelevant, because there is no control and experimental group. None of the relevant threats, none of the threats that are relevant to this design, like mortality or attrition, maturation or history, they are not controlled for. Even if the research participants, after receiving the treatment, score high on the post-test, we cannot attribute their performance to the treatment since we did not know what they were before being administered the treatment. This is an extremely, extremely weak design. So if you have a choice between using this design and not doing a study, probably a good idea not to do the study. That's your attitude if you're wearing your formal researcher's hat. However, as mentioned earlier, it has some utility if used to test out a preliminary idea before launching into a full-blown research study. And this might be your position if you were wearing your teacher researcher's hat. So it may have some value in examining something going on within your classroom. Let's move on to the next design. In the one group pre-test, post-test design, the one that's on your screen now, a single group is pre-tested, then receives a treatment, that's the X in the middle, and then some kind of post-test. The success of the treatment or intervention is determined by comparing pre-test and post-test scores. This design controls for some areas of invalidity not controlled for by the one-shot case study design, and you can see the checked blue boxes on the bottom left of your screen, but many threats are not controlled for. If participants score better on the post-test than on the pre-test, it cannot be assumed that the treatment was the reason for the better pre-test performance. The threats of history and maturation are not controlled for. Something may happen during the course of the treatment that may have influenced the participants' scores. And as we know, when history or maturation is involved, the longer that the study goes on, the more likely these threats can play a role. Testing the possible effects of taking a pre-test and post-test and instrumentation where it's possible that the pretest and post-test were not equally difficult, are also not controlled for with this study. Also, statistical regression is not controlled for. It's possible that by chance alone, participants score unusually low on the pretest and, as would be expected, to regress towards the mean on the post-test, indicating an improvement or a higher score that might be assumed to be the result of the treatment, when in reality, it's simply statistical regression. Although the one-group pretest post-test design is an improvement over the one-shot case study design, it still remains a weak design with many threats to validity not checked for. And this is your position if you're in your formal researcher's hat. However, again, keep in mind the distinction between your formal researcher's hat and their purpose, and you're conducting a study when you're wearing your teacher researcher's hat. This design might be very appropriate as an action research study conducted within the confines of your classroom. And this obviously would be when you're wearing your teacher researcher's hat. Well, let's go on. The static group comparison design has two groups. One group, group number 1 on your screen, receives a new or experimental treatment, and the other group, group number 2 on your screen, receives a traditional or control treatment. And then both groups are post-tested. It's common to refer to the one group as the experimental group and the other as the control group. However, it's probably more accurate to refer to both groups as comparison groups, since we are comparing the groups to each other. The purpose of the control group is to indicate what the performance of the experimental group would have been if it had not received the experimental treatment. Obviously, for this to be the case, both groups have to be equivalent going into the research. The researcher has to make sure that the two groups are equivalent on whatever the variable is that's of interest. In terms of threats to validity, history is controlled for because it assumed that any historical event, the flu epidemic or something like that, would affect both the groups in a similar manner. The testing and instrumentation threats are controlled for because the same post-test would be used for both groups. Also, statistical regression to the mean is controlled for because there is only one test given. Although the design has limitations, this is if you're wearing your formal researcher's hat, it can be useful again as a preliminary exploratory study. That's your teacher researcher's hat speaking. It's important to consider the different purposes of the formal researcher and your teacher researcher. Well, okay, that is the 3 pre-experimental designs. So we have just covered the 3 designs, the one-shot case study, the one group, pre-test, post-test, and the static group. Although the 3 designs are of little use again to formal researchers because of their lack of control over the threats to internal and external validity, they may have some utility for you as classroom teachers. Well, next we'll take a look at what's considered the gold standard of educational research, 2 true experimental research. And we're going to look at 3 true experimental research designs. The pre-test, post-test control group design, the post-test only control group design, and the Solomon 4 group design. Before we go into each of these designs in detail, a few reminders about true experimental research designs. Number 1, they are the only design that can establish a true cause and effect relationship between variables. Number 2, all true experimental designs have one thing in common that none of the other designs have. random assignment of participants to treatment groups. Now, ideally, participants should be randomly selected for the study and randomly assigned to groups within the study. However, to qualify as true experimental designs, there should be, at the very least, random assignment to groups. Another characteristic of true experimental designs is the manipulation of the treatment or the independent variable by the researcher. In other words, the researcher or researchers decides who gets the treatment or intervention and who is in the control group. And finally, these designs are loved by those who wear the formal researcher's hat. So we'll take a look at some true experimental designs. Okay, our first true experimental design is referred to the pre-test, post-test control group design, and it consists of at least two groups, each formed by random assignment. You can see in the red boxes, you have group 1 random assignment, group 2 random assignment. Each group is pre-tested, as you can see the green box, and then each group receives a different type of treatment or intervention, and each group is post-tested. So you can see the graphic. The top group gets the experimental treatment, the bottom group gets the traditional. The combination of random assignment to groups and the presence of a pretest and control group serve to control for all sources of internal validity. You can see the box at the lower left corner of your screen. Random assignment, which in essence creates equivalent treatment and control groups, controls for statistical regression and selection interactions. Suppose we wanted to study the effects of computer-assisted instruction versus traditional instruction on the quality of, let's say, written compositions of 9th grade students. And again, suppose we randomly selected 100 9th grade students from a population of all 9th grade students in a particular school district. Then we created two groups, one who received traditional composition instruction and the other received the computer-assisted instruction and composition. Next, we randomly assigned the 100 sample students to one of the two groups. The pretest is used to see if the groups are essentially the same on the dependent variable at the start of the study, in this case, the quality of their written composition. Then the experimental group is instructed using computer-assisted instruction, while the control group receives the traditional instruction. Post-test scores of both groups are compared. If the post-test scores of the experimental group are significantly different than the control group, a case can be made for the intervention that had an effect, since all sources of invalidity were controlled for. This is a very strong design, loved by formal researchers, but a difficult design for teacher researchers to implement in their classrooms. Next, we'll take a look at the post-test only control group design. This design is exactly the same as the pre-test, post-test control group design, except there's no pretest. Participants are randomly assigned to groups. They're exposed to different treatments. One gets an experimental treatment, one gets traditional treatment, and then they're post-tested. Post-test scores are then compared to determine the effectiveness of the treatment. Due to the random assignment to groups, basically assuring that both groups are equivalent, and the presence of a control group, that's the group that gets the traditional treatment, these factors serve to control for all threats to internal validity. And you'll notice in the box at the bottom left corner, all the threats are checked. That means they're controlled for. As in the pre-test, post-test control group design, scores of both groups are compared. If the post-test scores of the experimental group are significantly different than the control group, a case can be made that the intervention had an effect since all sources of invalidity were controlled for. Okay, now we'll take a look at the last of the three true experimental designs is the Solomon 4-group design. And you can see the graphic on your screen. In the Solomon 4-group design, we have random assignment of participants to one of 4 groups. 2 groups are pre-tested and 2 groups are not pre-tested. One of the pre-tested groups receives the experimental treatment. One of the unpretested groups receives the experimental treatment. All 4 groups are post-tested on the dependent variable. And you can take a look at the graphic on your screen. This design is a combination of the previous 2 true experimental designs, the pre-test post-test control group design and the post-test only control group design. Like other true experimental designs, this design controls for all threats to internal validity. Although this is an excellent design, it may not always be the best choice. For one thing, the design requires twice as many participants as most other true experimental designs. As a general rule of thumb, which design is best to choose depends on the nature of the study and the conditions under which the study is conducted. It may be unlikely that you will use a true experimental design for your master's thesis. However, it is still a good idea to be cognizant of the different research designs, their strengths and limitations, and how they control for the internal and external validity. This information will make you a much more critical and analytical consumer of educational research. Okay, so we have looked at 3 pre-experimental research designs and 3 true experimental research designs. When it's not possible to randomly assign individual participants to groups, entire classrooms, not individual students, may be assigned to treatment and control groups. When this is the case, there are still a number of designs that provide adequate control of sources of invalidity. These designs are referred to as quasi-experimental designs, and we're going to take a look at 2 of them. The first quasi-experimental design is the non-equivalent control group design. It's very much like the true experimental pre-test, post-test control group design. The major difference is that the non-equivalent control group design involves random assignment of intact groups, generally classrooms, and not random assignments of individuals. 2 or more treatment groups are pre-tested, given a treatment, either experimental or traditional treatment, and then post-tested. And you can take a look at the graphic there. This design does not control for the threats of statistical regression and selection interactions between maturation, history, and testing because the intact groups may not be equivalent. Remember, the researcher had to use intact classroom groups, so they not necessarily are not equivalent. If they could be random assigned groups, individuals randomly assigned, that could control for that, but this doesn't. So obviously, this study will be a lot stronger. The more similar that the 2 groups are, the intact groups are, will make the study stronger. Comparing a high-functioning intact classroom with a low-functioning intact classroom would be comparing unequivalent groups, and that's one of the major threats of this design. This can be a useful design when it is not possible to randomly assign participants to groups, as often happens within schools. So that's the non-equivalent control group design. And let's take a look at the last of the quasi-experimental designs. This is the time series design, and it's actually an extension of the one group post-test design. In this design, one group is repeatedly pre-tested until their scores have stabilized, until they are continually getting about the same score. Then the group receives a treatment, and then the group is repeatedly post-tested. If the group scores the same on the number of pre-tests and then significantly improves following the treatment, we can be fairly confident in the effects of the treatment. History still presents a threat to the internal validity of the study because a significant event might have taken place between the last pre-test and the first post-test, in other words, during the treatment stage. Instrumentation can present a threat if the researcher switches measuring instruments during the study, in other words, if the pre-test and post-test were not equivalent. Results are generally determined by viewing data presented in the form of a graph. So suppose we had a classroom that tended to be very noisy and disruptive, and we decided to take daily data on the level of the noise in the classroom. And we collect this initial data, let's say for about 15 days. And then we introduce an intervention, longer recess time for appropriate behavior. We're going to give the class a longer recess time if their behavior is appropriate. We then begin to take post-test noise level data. If we plotted our data on a graph, it might look like the graph on the bottom right of your screen. So obviously you can see a lot of noise at the beginning, then there was the intervention and the noise dropped way down. So obviously in this scenario, the intervention of increased recess time worked quite well. This is an excellent design for classroom use, whether you are working with an entire class or just some individuals within the class. You'll see a very similar design when we take a look at what are referred to as single case research designs, but more about that later. Well, okay, we have covered the 3 pre-experimental research designs, 3 true experimental research designs, and 2 quasi-experimental research designs. These are by far not the only types of research designs, but generally they're the more common ones. Again, as graduate students, you will be reading results of research studies, and it's a very good idea to have an understanding of the different research designs and their strengths and limitations. It'll make you a more intelligent consumer of research. Okay, well now, this is on you. Written assignment. Select one of the 3 true experimental designs or select one of the 2 quasi-experimental designs and design a fictitious research study. Give your study a name, define your dependent variable or variables and independent variable or variables. Write out your research procedures, including participants in the study, in other words, who are in the study, the setting, where is the study taking place, your theoretical data collection procedures, how you would go about collecting data, your data analysis procedures. Then create some dummy data, just make up data for your study. Report your results, and then evaluate your study in terms of its internal and external validity. Explain how you controlled or did not control for threats to internal and external validity. Then I'd like you to add this to your assignment, to the document you've created for assignment number 2. And when you have completed all of assignment number 2, please email me your document at happyj1939@yahoo.com. If you are interested in the sources used in the material in this video, here they are. Thank you very much, and we'll see you in the next video.